Okay, so what we're working on today is solving polynomial equations. Now, that just means when you have an equation and you have an x squared, x cubed, x to the fourth, and you want to solve and find all the solutions. Well, an x squared equation is not too difficult. You have a few options to solve it. You could use factoring, you could use completing the square, or quadratic formula. But what happens when you don't have an x squared? We have to use other methods. So there are some steps that we're going to take to be able to find the solution of an equation, for example, an x cubed equation. Step 1, list all the possible rational roots. Now, we've already talked about possible rational roots, and that would be to take the factors of the constant, in this case it's 8, and let me use a different color. I'll use blue. The factors of 8 are 1 times 8 and 2 times 4. And then I'm going to put those over, make fractions, of the factors of the constant over the factors of the leading coefficient. Well, the factors of 1 are 1 and 1. So, I'm going to list my possible rational roots by taking each of these numbers and putting them over these. Now, there's 2 rules with a list of any set, or any type of set. The 2 rules are, number 1, no repeats, and number 2, put your answers in numerical order. So, I have 1 over 1, 2 over 1, 4 over 1, and 8 over 1. Now, if I broke it into a 1 and a 1, really, if I did this over the other one, I would just have a repeat of everything I've already written, so I'm done. Remember, it's the factors of the constant over the factors of the leading coefficient and never the other way around. I'm done. These are my possible rational roots. Now, step 2. Use synthetic division to find a solution. How do you know if you found a solution? If you have a remainder of 0. So let's do a little bit of synthetic division here. I hope I have enough room. Let's write our coefficients down. 1, negative 3, negative 6, and 8. I'm going to make my little box. And I'm looking for one that has a 0. Now, I've told you many times that I recommend that we do not use the highest number, because what I want you to take into consideration is the concept of the upper bound and the lower bound. But we'll get to that in a moment. So let's start with 4. Okay, let's plug it in. Synthetic division says bring the first number straight down. 4 times 1 is 4. Add them and get 1. 4 times 1 is 4. Add them and get negative 2. 4 times negative 2 is negative 8. Uh-oh. Add them and get 0. Yay! So I found a solution. Remember, your goal is to solve for x. Now, if you remember the fundamental theorem of algebra, the corollary, it says that if you are looking at a third degree polynomial, that is, the highest power is in x to the third, then you will have 3 solutions. If your highest power was in x to the fourth, then you would have 4 solutions. So I'm looking for 3 solutions, and I just found one. And that one is 4. So I'm going to go ahead and put that on my list. I found one of the solutions. Now, I just mentioned at the beginning that if you have an x squared polynomial, we already kind of know how to find those solutions. Factor, complete the square, or quadratic formula. These numbers that are left at the bottom of my synthetic division tell me something important. They tell me that when I divide by x minus 4, I am left with a 1x squared plus a 1x minus 2, remainder 0. This is very important to me because I found one root, 1, 0, one solution, and this represents the other 2. For example, if I said, name for me all the factors of 48. Well, if I thought about it and I said, break it down into all of its factors, well, I know 2 goes into 48, right? So when I divide 2 into 48, I get 24. So that means, yes, 2 is a factor of 48. Now I can look at the 24 and go from there and break that down from there. That's what I'm doing. I found that 4 was a solution. X minus 4 is a factor because I have a 0 remainder. So what I'm going to do is take what I have left over after I divide it, and I'm going to go from there and break this down. I am looking at an x squared. I can factor this. X squared is x times x. What two numbers multiply to give me 2 and subtract to give me 1? That would be a 2 and a 1. To get a positive 1, that would be a positive 2 and a minus 1. So this factors into these two, and I can see my other two solutions. What value of x makes this 0? X is negative 2. What value of x makes this 0? Positive 1. So that means my other two solutions must be negative 2 and positive 1. And if I have put a negative 2 in to synthetic division, it should also give me a 0 remainder, as will 1. Let's try this again. All right. Example 2. X cubed minus x minus 6 equals 0. Now I have a trick in here. There's a missing term, so you have to be very, very careful with that. But I'm still going to follow my 4 steps. By the way, I didn't actually review those. Number 3 and number 4. Number 3 I'm going to reserve until we get to the third example. All right, I'll bring this back up. Number 4 says use factoring or quadratic formula to find the final solutions, and we did that right here. Okay, so I'll come back to that number 3 in just a moment. All right, x cubed minus x minus 6 equals 0. I have 3 solutions because it's an x to the third. Step 1, possible rational roots. So my possible rational roots are plus or minus, don't forget those, the factors of 6. 6 is 1 times 6 or 2 times 3 over the factors of 1. So far I've been lucky. When I list my possible rational roots, I have 1 over 1, 2 over 1, 3 over 1, and 6 over 1. And I don't come back the other way. All right, now I'm going to start using step 2, synthetic division, to find a solution, a 0, a root, a remainder of 0. All right, so I have to be extra careful because if I am going to do synthetic division, I'm going to pick a number and put it in the box. I want to write these coefficients, but I have to account for any missing terms. So I have a 0, a negative 1, and a negative 6. All right. I mentioned to you earlier that I don't recommend you start with the highest number, and I am about to show you why. Let's plug in a 3. All right. Bring down the 1. 3 times 1 is 3. 0 and 3 adds up to 3. 3 times 3 is 9. Negative 1 plus 9 is 8. 3 times 8 is 24. Add them and get 18. Is 3 a solution? No, it's not. However, notice in my answers, not only is it not a solution or a remainder of 0, all of my values I have down here have the exact same sign. This is what we call an upper bound. After you do synthetic division, when all of your values are left at the bottom, if they have exactly the same sign, positive or negative, it's usually positive. But either way, that means you have an upper bound. That's that high-low game, okay? If I have an upper bound, that means not only does this not work, nothing higher will work. Don't waste your time. So there is no need for me to even try a 6. Unless I did this wrong, but let's not go there. All right, so let's try 2. 1, 0, negative 1, negative 6. 3 didn't work, now I'm going to try 2. Bring down the 1. 2 times 1 is 2. Add them and get 2. 2 times 2 is 4. Add and get 3. 2 times 3 is 6. Hello. Add them and get 0. I found a solution. Yes. So, let's see. I can put that up here. X equals, and I found 2 works. Now, this represents x squared plus 2x plus 3. Can I factor this? What 2 numbers multiply to give me 3 that add up to 2? Nothing. They don't. They'd subtract. 3 and 1 subtract to give me 2, but I don't have a subtraction here. It won't work. This will not factor. So, let's go back to this and see. Use factoring or the quadratic formula to find the final solutions. Factoring didn't work. I got to use quadratic formula. So let's go over here and take x squared plus 2x plus 3 and put it into the quadratic formula. If you remember it, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, technically, I can use this, but here's a, b, and c right here. 1, 2, 3. So, negative b is 2. Negative 2 plus or minus the square root of 2 squared minus 4 times a, which is 1, times c, which is 3. Yeah, go ahead and put it in there. All over 2 times a. Negative 2 plus or minus 2 squared is 4. 4 times 1 times 3 is 12, and there's 1 minus sign, all over 2. Oh goodness, this is going to be a fun one. 4 minus 12 is negative 8. I can break down negative 8. Ooh, fun one. All right, break down negative 8. 8 is 2 times 4. 4 is 2 times 2. But a negative 8 is times negative 1. Sorry about that. Let's see if I can fix that. I have a pair of 2's. Cross it off. Write it once on the outside. I have a negative 1. What's square root of negative 1? I just found imaginary answers. And whoopsie, this whole thing was over 2. I have negative 2 plus or minus, I hope you can see this, 2i over 2. We usually won't go this far, but I should still reduce because all 3 terms can be divided by 2. So when I divide everything by 2, I get my other 2 answers, which are negative 2, sorry, messed up already, negative 1 plus or minus I. So when I divide by 2, I get negative 1. When I divide by 2, I get I. When I divide by 2, I get 1. If you want to write over 1, that's fine. I don't mind. And there, that one had pretty much everything. That one had possible rational roots. Oh, look, we had an upper bound. Oh, look, we found a solution. We took what was left over, put it into quadratic formula because it wouldn't factor. And then when we did quadratic formula, we had to keep simplifying. We had to break down our square root and reduce our final fraction. Can't hit you with much more than that. I can, but not too much more. All right, let's try one more. And I'm going to put this one, oh, and I'm going to hit myself in the chin with it. Great, you'll enjoy that. Okay. Here comes a fun one, x to the 4th. Because I've had a few of you asking me about this. Same exact process. Possible rational roots are plus or minus the square root of, everything's over 1 again. Yes, the factors of 18. are 1 times 18, 2 times 9, and 3 times 6. So put them each over 1, and I get 1, 2, 3, 6, 9, and 18. Now, so far we haven't had to worry about the negatives, and I know the answer already ahead of time. So again, we get to avoid the negatives on this one. We will get a positive one. But let's try, since we have so many, I can try 9. I could try 6. It really doesn't matter. I don't want to try 18. Okay, so let's see. I will try 9. Although it's pretty large, and I'm kind of guessing with this 16 and 15, I'm going to dread this. 1. I am missing a term, so I have to put in my 0. Ooh, watch out for that. Whoops, sorry about that. Weird looking 15. Bring down the 1 times 9. Add them. Oh boy, here we go. This is a mistake. I'm going to do this in my head. I'm not ready for this. 9 times 9 is 81. Subtract, add, put them together, and I get 65. Times 9. 540 plus another 45 is 595. Okay. I'm going to go with a no on this one. I'm going to go with it's not going to give me 0. I'm just getting massive numbers. And I'm also looking ahead and thinking, this is going to be a hugely positive number. Times 9 is going to give me a much more higher positive number. So I'm going to end up with all positives. I'm pretty sure 9 is not just a no, but it's also an upper bound. So let's skip. Because my numbers are getting so high, I'm guessing 6 probably won't bring them down enough. Let's go to 3. All right, 1, 0, negative 16, 15, 18. 1 times 3. Add times 3. Add times 3. Add times 3. Uh-oh. I got 1. All right. I found a solution. So remember, we should go write these up here. X equals 3. 3 works. I'll give you a hint. I already know 6 is just going to be like 9. It's not going to work, and it gives me too high of a solution. So the question is, what do I do now? This does not represent an x squared. It's a 1x cubed plus a 3x squared minus a 7x minus 6. I can't use quadratic formula. Sometimes when you have 4 terms, you can break it into 2 and 2, but these won't give me anything that I can work with. I can't factor it. I can't use quadratic formula. I don't know what to do. This is where step 3 comes back into play. I hope you can see this. It says go back to step 2 until you work down to a polynomial x squared. What does that mean? What I mean is this. We divided an x to the 4th. We found a solution. We got it down to an x cubed. Now we need it to be an x squared. So what I'm going to do is I'm going to take my solution and keep doing more synthetic division. I'm going to use my same list. I'm just going to keep working on it. Okay? If I want to know the factors of 48, and I want to know if 7 goes into 48, but I'm not sure. Okay, divide by 2. 2 goes into 48. What am I left with? 24. Does 7 go into 24? No. If it didn't go into 24, if it does not go into 24, then it wouldn't have gone into 48. A factor goes into the number. If 9 didn't work for this, 9 is not going to work for this. So I'm going to keep using the ones I haven't used, but I'm not going to go back to my same x to the 4th numbers. I'm going to use my x to the 3rd numbers. 3, negative 7, and negative 6. And I'm going to do some more synthetic division. Okay? I already know 18 doesn't work, 9 doesn't work, I'm pretty darn sure 6 isn't going to work, and I already found 3. So let's go to 2. Bring down the 1. 1 times 2. Add. Times 2. Add. Uh-oh. Times 2. I see it. Add. I found a solution. So 0 is my remainder. 2 works also. I'm going to put 2 on my list. And guess what I now have? I have a 1 and a 5 and a 3, which represents an x squared. That can't be factored. Darn it. No numbers multiply to give me 3, but add to 5. So let's use quadratic formula. X equals a, b, c. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Let's try it again. Negative 5 plus or minus 25, whoopsie, minus 12 all over 2. My other two solutions are negative 5 plus or minus the square root of 13 over 2. And because I don't know if let's try it here. Negative 5 plus or minus the square root of 13 over 2. I found my 4 solutions. I got them. Okay? There we go. When you have an x to the third, use possible rational roots. Start putting them into synthetic division. Keep in mind the upper bound concept until you find a 0 solution. And then what's left over would be an x squared. And you can either factor it or use quadratic formula. If you have an x to the 4th, you would find a solution, but what's left is an x cubed, so you just keep going. Use your x cubed numbers. Keep using numbers you haven't used yet from synthetic division until you find a second one. When you find the second one, what's left will be your x squared, and you can then plug it into quadratic formula or hopefully be able to factor it and make it easier. Good luck. Bye.